Yeah, we talked a little bit about RRR assessment. So how to best do RRR assessment. This is what you're working on right now. So I showed you the first example with Hart and Albericin, why we are doing this kind of thing, because there's all sorts of issues that we can check and do when, when we're looking at an RRR and the original, we can find all sorts of things that other people throughout the decades since the original have not been able to track. And sometimes this leads to all sorts of insights, like for example, in the case that we talked about before, we even found some indications for fraud. So we really need somebody to go over this. We don't do this in academia. So we do this together, you and I, in this course. So the usual stuff that I start with, you've completed team contracts, so well done. You've completed the first month, well done. Only 2 months to go, only 3 more assignments left for you. All the stuff with the RR assessment task, so I think by now you already know. You have 2 tutorials, Christy and Kit, and then you have Chinyu that did a tutorial on effect sizes with an amazing guide. And then these lectures, so this one and the previous one, are about RRR assessment. I'm going to show you again why RRR assessments are important. We're going to go over some of the basics that we've learned from last time to make sure that we remember and we understand what these things are. What is an effect size, confidence intervals, less statistics, more looking hands-on, like on things. And like you mentioned, 2020, 2019, we have some templates. Plus, I posted this on Slack. I'm not joking. Already yesterday, some of the other teams told me that they found issues with the thesis that was written with me. You'll get money. If you find errors in the thesis conducted with me, I guarantee you'll get paid for this. If it's a minor thing, it's like $5 US. If it's a major thing, it's like 400 Hong Kong dollars. So please help us do better. Next semester, some people will be going over your stuff. So we help one another, lots of checks and balances. You get assistance from the teaching assistants, you get assistance from the instructor, you get assistance from the entire community on Twitter, and then you get assistance from future students that will look at your work. So some of you might be thinking, I don't know what I'm doing. What are all these effect sizes and statistics? I don't know if I will make an error. Making errors is okay. Mistakes happen, we will help you. However, the most important thing to focus on is comprehensiveness. Tell us what you did so we understand your mindset, and be completely transparent about everything. So it's much better to say, I don't know what this is, but this is what I tried, to saying, I know for a fact that this is the solution, when maybe it's not the solution. So it's good to share some of the things that we don't know. Sometimes you'll see me commenting on Slack. When you ask me, and I don't know, let me ask on Twitter, let me ask other professionals, and I'll get back to you with an answer. This is how we learn. So the more that you comment, the more that you ask me, the more that you tell me what it is that you don't understand, don't be shy. Don't feel like you're silly or stupid or anything like that. Quite the contrary. You're helping both yourself, the other students, and myself to do better. And we get to improve the templates together. The teaching assistants are also learning through this. So together, we all aim to improve both ourselves and science. Okay, so last time we were talking about our assessments and how we evaluate things, and this is a continuation of that. How do we evaluate findings in articles and results of replication attempts? If you recall, last thing we were talking about was priming effects. 1996, elderly priming, very classic experiment that led to a prolific line of research, hundreds of articles, a lot of findings that use the same kind of method. You unscramble sentences with all sorts of words that might be associated with elderly, like Florida or slow. And then somehow when you measure how fast they walk from the entrance to the elevator, then they walk slower. So we saw a video of a BBC production that tried to reproduce what it is that they've done with 2 experimenters. One is the TV host, the other one is a UCL researcher. And we've contemplated a little bit what is going on over there, what are some of the weaknesses. So the last thing that we had was a quote from John Barge, who did the elderly priming, saying, I do these simple manipulations and somehow it creates these big effects in behavior. And then our question is, does it really do all these things? Now, the second thing I want to show you, we didn't go into this in much detail, but I do want to share this with you because, again, by John Barge and one of his students, this is a real article. It doesn't happen very often in social psychology that we get a paper published in Science, Nature, top journals, top 2, really high impact. Everything that you publish over there, you're going to get a lot of citations. So a student of John Barge, you can see over here, the cited by. You've got Williams and Barge science paper from 2008, cited by 1,762. What was this paper? Also a continuation of priming. It's 12 years after the original elderly priming. And what they wrote is, experiencing physical warmth promotes interpersonal warmth. So in our brains, the main argument is, in our brains, we associate hot, warm, with feeling very warm towards another person. Yeah, so in English, there's this strong association. Sometimes we use temperature in order to convey our feelings. So when we feel very warm about something, it's like we're feeling togetherness, we feel very strong connection. And cold is something that's, if you're feeling that I'm cold, then I'm distant and I'm not with you, there's like a barrier between us. So they said, perhaps if we prime this, how do you prime warmth and coldness? You give people mugs, they're either very warm, very cold, and then you try and evaluate how they assess other people, whether they're warm or not. So let's look at this. Warmth is the most powerful, the most personality trait in social judgment. I don't know why even these kind of statements, but okay. And attachment theorists stress the importance of warm physical contact with caregivers during infancy and healthy relationships in adulthood. So they had all sorts of experiments. In study 1, participants who briefly held a cup of hot beverage versus iced beverage, coffee, judged a target person, so when judging another person, as having warmer personality. Warmer meaning more generous, more caring. In study 2, participants holding a hot versus cold pad were more likely to choose a gift for a friend rather than for themselves. So more pro-social behavior rather than for yourself. When this was published in Science, we all thought, this is amazing. So a social psychology study published in Science, that means that it's very, very solid and very good evidence. However, but when we look at actually the statistics, we see over here that as hypothesized, people who had briefly held the hot coffee cup perceived the target as being significantly warmer with a mean of 4.71 compared to the ice, 4.25, and then you have the F for ANOVA. F statistics, what is the p-value? Exactly, 0.05. How many participants are here? So we have the degrees of freedom. So we have the degrees of freedom here. But then also we have this up here. We recruited 41 undergraduates. And over here, we already had, how many were there in the other one? 53 participants. So 2 studies, 41, 53. So before, when I did the simulation and I showed you some p-hacking, I was kind of joking around that the standards are 20 per condition, and then you can get a Science Nature paper. No longer the case. But back then in 2008, that's all you needed to get a science paper. So you can evaluate, first of all, the claims here. Are the claims, do they sound reasonable? Do they make sense to you? Then the manipulations, do the manipulations seem like they're very strong to you? Then the dependent variables, do the dependent variables really speak? Is there like a connection between the dependent variables and what they're arguing in their hypothesis? And then you can evaluate the statistics. Are the statistics reasonable? How strong is the evidence? What is the effect size? Confidence intervals? P-value? What is the large or small sample size? How well powered is this sample? So looking at all this together before we go into the actual video and see what it is that they've done, how would you evaluate this as the original article? Let's say that you're about to replicate this. What is your assessment of this just based on what I showed you over here? What's your evaluation? The standard deviation is not reported. Yeah, that's the reporting standards. Unfortunately, in science, they don't report anything. This is already more than what they usually report. But yeah, not only that, but we also don't know each condition had how many participants. So we really want fuller transparency. But back then, actually, even today, a lot of people don't report these kinds of things. However, we can do some things in order to get this indirectly from the F statistic to some extent, if we assume equal distribution of participants. That's good. What are your evaluations of this? Strong, weak, 3 weeks? Okay. So to us in 2008, very strong, amazing. Why? Because science paper. Why? John Barge, come on, John Barge. Big figure in our field, big journal. Who actually goes and reads the statistics? Many years later, you do, or some other replicators do. So we really, when we look at a science paper, we have this immediate appreciation for it, but we don't, this is not enough just because you come from a certain school or you publish in a certain journal. That's not enough. You really need to go into the statistics and have a look at this. So we're going to watch the video. I want you to do the same kind of exercise, just like we did looking at the article. I want you to keep an eye on the video and write down for yourself, so we can discuss this later, all the things that you think might be wrong about this experiment. Okay? So you're the assessors. You're the ones who are evaluating this research. Should it be published, not be published, just based on this simulation.
To a warm or cold substance. And what we expect to happen is that that simple experience with a warm substance or a cold substance will prime people to sort of activate these feelings of warmth and comfort and the things that we've learned about since we were very young. And when we have those things in mind, those things we know will color people's judgments and decisions and their behaviors as well.
Volunteers for the experiment are asked to hold a warm cup of coffee as they are met by Lawrence. They have been primed with heat. The purpose of the experiment is to record participants' judgments about Lawrence's colleague, Randy.
How was your break?
It was awesome.
It was good until I got stranded in Florida.
What happened?
Because of the snowstorm
in
New York on Friday, so I got stranded.
The theory is that the hot drink will somehow elicit positive feelings towards Randy, even several minutes after experiencing the warmth of the cup. And here's the killer question. Would you give Randy a permanent job?
Based on your brief interaction with Randy, or would you hire him as project manager?
He seemed like a generally friendly guy. So yeah, I would say so.
Yeah, why not?
Sure. Yes. Yes.
Saying warm and friendly things about a stranger might just be the normal polite response. Time to cool things down. Except for the temperature of the drink. Identical conditions. The same conversation with Randy.
How was your break? You glad to be back?
Not really.
And 6 minutes later, the same questions from Lawrence.
Based on your brief interaction with him, would you recommend him or would you hire Randy as project manager?
As a leader? I'm not sure. Based on the brief interaction? No.
Maybe not from the impression that I got.
The experiment shows, remarkably, that a brief encounter with a beverage could see you either hired or fired. It's a powerful effect, and one that might have worrying applications.
In the case of, say, consumer products, feeling warm about a product presumably will make you more likely to buy it. Feeling warm about a spokesperson may make you be more likely to listen to that person and trust their judgment.
So beware politicians handing you cups of coffee, right?
Essentially, yes.
People say, how can you get these effects with such rinky-dink little manipulations and moving people's behavior all over the place? And I don't know, it just keeps working.
So the BBC summarizes this is a powerful effect. So now let's discuss the powerful effect that you see over here. What kind of things did you see? What did you notice in this kind of experiment as assessors? So experimenters knew the hypothesis, which affected things how? Yes. Yeah, so what, for example, here, where could you see this happening? This is actually, it's not only the experimenter, he's also the person who wrote the study, designed the study. So what did you see with Williams? So when they're giving the cup, so when the experimenter is giving the cup, he will do something different. For example, he would smile if it's warm, and if it's cold, he would do something else. Consciously or subconsciously, very good. So actually, we discussed last week that this is actually what they found when they tried to replicate this. So very good. Anything else that you've noticed? What else is in here? All right, so at least in this demonstration of the BBC, they've really summarized things and focused on only some of the participants, and maybe this participant, the participants that they interviewed don't seem to be a good representation of everybody in that sample. Very good. Anything else that you noticed? Let's take it one by one. How about the intervention? So they do an intervention. One person gets the hot, some participants are randomized into the hot condition where they get a hot coffee mug, and then the others get, like say, a cold Coke. What could be a problem with this intervention? What would be a control variable in this case? Getting nothing at all. Good. So adding another control condition to check which one is it. Perhaps it's the warm or is it the cold. So comparing this to the control condition. Okay. So one more condition missing. What else? Very good. How about the measurement? The dependent variable. How do they measure? Because Randy, he's a confederate. He's an actor, right? So the confederate, they need to evaluate him whether he should get the job or not. So this is supposed to indicate some kind of feelings of warmth by deciding whether this person should be hired or not. What are some of the possible issues in this kind of thing? So the way things are here, the person holds, so first of all, it's in an elevator, so a very small elevator. So you come in and you stand with the experimenter. Sometimes, we don't know when, there's another person there taking the elevator. Then he gives them the coffee or the Coke, the cold. And then some people take it like this, some people take it like this, some people hold with both hands, some people hold with one hand. Already some differences in how the intervention happened. What are the circumstances? Then they get out of the elevator and they walk together, and the experimenter takes the cup. Sometimes it could be a few minutes afterwards. And they come in, they meet the person, they interview them, a few more minutes pass, and then only after that, they measure the dependent variable. So there's a big lag between the intervention and the dependent variable, which is the measurement. So looking at all these factors together, the question is, what do we expect as an effect size? A lot of these things are very indirect, very implicit. Some of these things vary according to the context, according to the participant, according to the experimenter, according to the confederate. A lot of noise. If there's a lot of noise, even if the phenomenon is very strong, which is not in this case because everything is very implicit, even if it's very strong, there's going to be some differences. In order to account for this kind of thing, you need very large sample size. In order to reduce the noise, you need to control things better. You need to make sure that everybody is holding the same thing, that the experimenters don't know what the hypotheses are, that the confederate doesn't know what the hypotheses are, that you treat them exactly the same way, whether you have a protocol, you sit the same way, they're seated in the same way, they're using exactly the same kind of method in order to rate. A lot of problems here. And this is only a simulation. If you get to participate in one of the labs here, we do some elaborate things at HKU. A whole night of sleep in some hotel, in designated place, you have a whole night to do, then measuring EEGs, looking at the brain mapping and all that. A lot of noise, a lot of complexity. You have the experimenters, then you have the lab member who's running the whole thing, then you have the PI, the principal investigator. All these factors require a very large sample and a very tight control, but it's very difficult to control things, especially when we do things in the field. In this course, in your replications and extensions, things are going to be relatively well controlled because everybody is going to see exactly the same Qualtrics. Qualtrics is exactly the same. We don't know where people are sitting and doing this kind of thing, but they will have a screen, they will look at the screen, and they will go through the screen. But when we do some of the more elaborate things at HQ or in psychology in general, a lot of noise, a lot of problems. So we need to be very, very careful about how we control all sorts of things, but also when we see the results, we need to think, is this plausible? Can this really make sense? I'll just run this till the end to see what John Barge says about all these things. I already saw his big quote sentence.
We do these things and they work, and that's, sorry, but they do. And now our job is to understand and try to explain to people why that is. Why it is the human mind is constructed in a way that you can get these effects at all.
Yeah, so the question is really, when you're being interviewed about this as a researcher, first of all, in the science paper, we already saw that they're going further than what they did in the actual experiment, right? They're saying all sorts of things about, he was interviewing them about, maybe it's about politicians who are giving you, coffee in order to get you to think more warmly about them. So they did one study, but then they're really overclaiming everything just based on this one study. And just like mentioned before, we covered this very, very briefly, the hot and the cold of priming, when they actually reran this as a replication, they were not able to get the same kind of results unless the experimenter had known of the hypothesis. So it could be that the experimenters are kind of creating the effect by doing all sorts of other things, like, for example, just being more warm towards the person. So actually, the typical experiment that we need to do in this kind of thing is that the experimenters do not know. So it's okay that you as the designers of the experiment know what the hypothesis is, but whoever is running your experiment, in this case Qualtrics, doesn't know what your hypothesis is and really does the randomization well. So PLOS1 is the only journal in 2012 that was willing to publish replications. If you would try to replicate this and publish this in any other journal, if you submit this to Science again and said, you published this paper 2008, we tried to replicate, we can't get this to work. So it's going to say, something is wrong with your article, something is wrong with your experiment, something is wrong. Who are you? What are you doing? PLOS1 was a revolutionary journal that really changed things in the field. When you ask John Barge, what do you feel about these replications? His response was not a positive one. And I say this as an understatement. So he wrote a post in Psychology Today. Actually, you can do this as well, because we have a column in Psychology Today. So if after this course, you want to write for Psychology Today, add another line in your CV, reflecting on what you've done in this course, you can. So just let me know. We have a few examples of students who have done this in previous semesters, which is only to say you don't need much in order to publish in Psychology Today. It's supposed to take academia and bring this to the public, and anybody can write a blog post. This is what John Barge decides to write in his blog, The Natural Unconscious. In response to the article on priming effects in social psychology, priming effects replicate just fine, thanks. And then he gives all these examples of why published replications of elderly priming effect. We've done this again and again. We've shown that this works. You have, maybe, you and your students. But how about external labs? If there are other people who can't replicate your work, what is the right reaction to this? Thank you very much. Let's figure this out together. Have a little bit of humility and then try to figure out what's wrong. This is how science improves. You don't just tell them, no, everything is okay, I've done this, therefore it works. This is not science. The science is a whole debate about trying to get closer to the truth. Priming effects on impression formation, sequential priming effects on social behavior. So he basically claims, we've replicated this many times, you have an issue, I don't know what you want from me. And very sadly, 2 years ago, even after he knows about all the failed replication of his work, he still published a book, which is now a New York Times bestseller, about how amazing priming is. and how you should get, people to hold hot coffee mugs if you want them to feel warm about you. Don't understand this sort of thing. Sanjay, who has another very interesting blog, it's called The Hardest Science. The hardest science, in this case, psychology, although it's not considered to be a hard science like physics, biology, chemistry. It's the hardest one because it involves humans, and humans are difficult to study and definitely understand. So he wrote this blog post. You can see this is March 2012, where he has some reflections about this paper that was published in PLOS1. And he said, beyond the failed replication, even if you put the replication aside, so when you're looking at your original articles, even before you started replication, you want to really look at the statistics and say, is this plausible? Does this make a lot of sense? So for example, what Sanjay did over here is reflect about the effect sizes. That being said, the effects in the original Barge et al. Report were big, like really big by psychology standards. In experiment 2A, the effect size was about 1. So we already saw from Hout and Albarisen, if you remember the effect size guidance from Cohen, which need to be updated, but 0.8 of Cohen's D is a strong effect. 1 is very, very strong. So if you've got very slight manipulations with all these indirect, implicit ways of measuring and manipulating things, you cannot have an effect of 1. The second one had the effect of 0.8, so very strong effect. So even if we account for some shrinkage, over time and all this, under the right conditions, it should not be hard for somebody to reproduce the elderly priming effect. So this is a reflection. It might seem very natural for us to think about this now and say, yeah, of course he's right. 2012, this was the middle of my PhD. I'm like, this is blasphemy. You're saying that priming doesn't work, the effect sizes are too large, but they've shown this and published this in Science. So really, it took a lot of people, for some this is still happening. It took a lot of time to start doubting these kinds of things. So we talked about some of the issues: tiny samples, unreasonably large effect sizes, experimenter or confederate biases, demand effects, overclaiming, and a lot of other things that we discussed. Daniel Kahneman is the only psychologist to ever win the Nobel Prize, because there is no Nobel Prize for psychology. There's only Nobel Prize, not even, but like a side prize for economics. So he's the only psychologist who ever won the Nobel Prize for economics, because he started a branch of economics that's called behavioral economics, or we call this in psychology judgment and decision making. This is what I do my research on. And he would have received the Nobel Prize together with Amos Tversky if Amos Tversky would have been alive, but he passed away in the 1990s, which is unfortunate. They've had a very, very close collaboration. Tversky and Kahneman really have revolutionized economics and our understanding of human nature. Why am I bringing Daniel Kahneman here? Because if I did a mistake about priming and I thought that priming is very, very solid, it was published in Science and John Barge, you would say, yeah, of course, you don't know anything. Nobel Prize winner, a psychologist. In 2011, published a bestseller. If you go to any bookstore in Hong Kong, this is translated to every possible language. Thinking Fast and Slow. I have to say, not an easy read. I don't understand how people last the entire book from beginning to end. It's good for academics like me in judgment decision making, but it's a little bit difficult for people to finish the whole book, but some really interesting insights. The only reason why he wrote this is because he got the Nobel Prize, and people say, come on, he wrote Nobel Prize. You have to summarize all your work. This year came another book, Noise, which I've been trying in various hikes again and again to listen to this, but it's kind of like a torture. It's not easy because it's not an easy book to read, even for an academic. Definitely not to listen to. So this book. Why am I sharing this book? Throughout my career as a PhD student in 2011, I did not read this book. Back then, I was not even in judgment and decision making. But everybody told me that I should read this book, and I didn't because I read a lot of other things for my PhD. By the end of the day, the last thing that you want is to open another book. So again and again, I postponed this. I finished my PhD in 2014, started a postdoc. Only in 2016, I discovered audiobooks. So I said, okay, now I can finally get used to this sort of thing. 2016, I went to the gym and I listened to this audiobook. First chapter, great. Second chapter, okay. Third chapter, fine. Then fourth and fifth chapter, suddenly there's a chapter about priming. And Daniel Kahneman talks about priming as the new direction in psychology. So 2011, before the replication attempts, saying that this seems to be a solid phenomenon, that we need to pay attention to this, and this seems like it's going, this is the future of where we're going as a science. So this is what he wrote. He was so worried about this. We didn't know this until 2016, but he actually wrote an email. And this is a copy-paste, a screenshot from the email, written in 2012, a proposal to deal with the questions about priming effects. So people started looking into these priming effects, some of the strongest effects allegedly in our literature, saying, but this doesn't seem to hold. We can't replicate this. Some of the things there don't make sense with effect sizes. So Daniel Kahneman says, as you all know, and he wrote this as an email to all the priming people, including John Bard, questions have been raised about the robustness of priming results. Your field, priming, is now the poster child for doubts about the integrity of psychological research. Because of you, people are now doubting everything else. People have now attached a question mark to the field, and it is your responsibility to remove it. This is his request as a Nobel Prize-winning psychologist. All I have personally at stake is that I recently wrote a book that emphasizes priming research as a new approach to the study of associative memory. Count me in as a general believer. Not just us, me, a PhD student. Nobel Prize-winning psychologist was a believer, and he wrote as much. He published this in his book, and he wrote this in an email. My reason for writing this is that I see a train wreck looming. If you can't solve this, if you can't show that this is replicable, we have a serious issue, not only with priming, but in psychology altogether. So what led to the exposure of this email? Uli, who does this blog, it's called Replicability Index, devised a statistical method in order to look at how robust a finding is. And he analyzed the chapter in Daniel Kahneman about priming. He looked at all of the literature over there. He put all the p-values, the effect sizes, and he made an analysis of how likely this is. And he came to the conclusion, this chapter is a disaster. Almost everything in there doesn't seem to be solid. So reconstruction of a train wreck, how priming research went off the rails. Now, the amazing thing is that Uli is known to people like me in the open science community, but he's not well known worldwide. So to everybody's amazement, an 80-year-old plus Daniel Kahneman went on the guy's blog and wrote this comment. 2017, Daniel Kahneman, what this blog gets absolutely right is that I place too much faith in underpowered studies. As pointed out in the blog and earlier by Andrew Gelman, who is a statistician, there is special irony in my mistake because in the first paper that Amos Tversky and I published that led to the Nobel Prize was about the belief in the law of small numbers, which allows researchers to trust results of underpowered studies with unreasonably small samples. Our articles was published in 1960, was written in 1969 and published in 1971. But I failed to internalize its message. How ironic is this? That if you go to the paper, belief in this is the thing that started the Nobel Prize, led to prospect theory. What did they do over there? This is what they did. They started. This is like the opening sentence of that article. Suppose you have run an experiment on 20 subjects and have obtained a significant result which confirms your theory with a p-value lower than 0.05. You now have cause to run an additional group of 10 subjects. Will it replicate? So he gave this to people. He said, you have a very small sample, just like in the science paper, and you found this kind of thing. How likely is it to replicate? And he showed But people don't take into account statistical error and noise. This is how everything started with heuristics and biases in judgment decision-making and behavioral economics. He even went to statistician conferences and asked statisticians, what would you say about this? How likely is it? And showed the statisticians make this mistake. So how ironic is that when faced with these kinds of studies published in Nature by people like John Bargh, he also made this mistake, which is very costly for him because his reputation is now on stake because there's a whole chapter in his book that doesn't seem solid at all. So it's not just you, I, the community, even the biggest experts who said and warned everybody that we should be careful about this, that human nature has weaknesses, that we're all very fragile. Even he fell into this trap. I think there's a big lesson for us in this kind of thing. We really need to think about how we process information. We really need to think about this academic system where there's reputation and everything that's published in Science and Nature is okay. Everything that comes out of John Bargh's lab is okay. The reason why you're doing RR assessments is because I really want you to look very carefully, both at the original and what it is that we do, because we need your objective eyes. You're still a clean slate. Nobody has ever brainwashed you. You're still at the stage where you're naive in a good way. I've been brainwashed again and again to look at these things and worship them. You haven't, which is why we need your help in assessing these sort of things. This paper, unlike the John Bargh, only 1,700 citations. How many citations for this? 4,200. And a lot of the papers by Kahneman and Tversky have been very impactful in this field. In your last assignment, we're going to ask you to look at cognitive biases in research, in researchers. One of you will get this, belief in small numbers. Other will get other cognitive biases. So I will want you to reflect on what it means that we have heuristics and biases and how we assess research. And it's not just for this, but also when we look at things that are related to misinformation regarding important stuff, medical stuff, health-related stuff, about vaccinations, about treatments, about COVID. It's related to everything that we do. Whenever you're going to go to industry, if you're going to education, if you're going to any other field of psychology, therapy, behavioral insights teams, whatever it is that you're going to do afterwards, even in finance, you need to know what kind of evidence you can look at and is solid and what is not. Now we have a bunch of tools. Instead of saying, do you trust this? What's your intuition? Now we say, let's use the tools. So people came out, I showed you a simulation of the P-curve by this team. So Uri Simonson, Leif and Joe Simmons. And what this P-curve actually shows is that if you take all the p-values of a certain domain, let's say priming research, you just take all the p-values in there and you put this and you analyze them. If there is no effect whatsoever, we would expect that the distribution of the p-value would be similar because there's no effect everything. You know, every p-value is as likely as the other. If there is some effect, like a coherence d of 0.3, we already see that this curve needs to be kind of a little bit, it's not a straight line. It leans towards the lower part. So the lower part needs to have more values than the 0.05. But the stronger the effect, and we're talking about effect of coherence d of 0.8 to 1 in the science paper, this is really what you would expect of a distribution of p-values. You would expect a lot of them to be significant. It's just like Sanjay said. It should be really easy to replicate this if the effect size is really that strong. So they've done this P-curve tool, and we've used this in the P-checker. If you don't remember, you can go back and revisit this. And when you put all the elderly priming values, it should look like this. But what you see is that most of the darts that you throw are just below 0.05 rather than most of them being here on the left side. So a big problem, and this is even just like 60% power. You can see the number of studies over there. And when you put this together, if you remember, I showed you with a simulation, this is what happened. So 44, so this blue line is the elderly priming literature. The green line is what you would naturally expect. And now we understand, of course, big problem in this literature. As a reminder to what we experienced last last session, we're going to do an example of another RRR assessment of a different target, a different replication. And this time it's ego depletion. We talked about ego depletion in the first class, and now we're going to revisit the replication findings. So I'll ask you to go on the Mentimeter. We're going to do this together. So you can write the analysis. There's no right or wrong, so I'm not going to grade you on all this. It's just for you to see whether you're able to do this kind of thing. So like this, yeah. So 1616781. All right. This is what we see from the RRR of ego depletion. The first question is, when you look at this forest plot and you try to make sense of it, we are focused right now on the original effect size. So the original one that they try to replicate, what is the effect size and what are the confidence intervals, and try to answer in this format. D, Cohen's D equals X dot XX, and then the confidence intervals in brackets. So looking at this, I don't know if you can see from very far or not, but yeah, what is the effect size and confidence intervals for the original effect of ego depletion? What's the way to approach this? Where is the original? The first row. The first row. Okay. What are the two numbers? The first two numbers. What are those? Experimental condition and control condition. So these numbers are what? The means of these two conditions. And then we have these lines that represent the confidence intervals. We have also this dotted line in the middle, which is the null effect, so 0. And we see that these confidence intervals do not overlap with the 0. And then over here on the right, we actually have the actual number of the effect size and the lower confidence intervals and the higher confidence interval. Right? So if we look at your responses, all of you got this correctly. So we have 0.68 with a confidence intervals of 0.09 and 1.27. Now, when we look at these confidence intervals, what do we know about this effect? What can you tell me about this effect? And this confidence interval, sorry? It's significant. Why is it significant? Right. So when we see that the confidence intervals do not overlap with the null, we can assume like it's a proxy for this being significant. So p-value lower than 0.05. Good. Next question. What is the meta-analytic effect size and confidence interval? So how do we look at the meta-analysis effect of all the replications? Where are the replications here? Sorry? Yeah, what is the line at the bottom? Yes, so that's the aggregated, summarized, meta-analytic effect size of all the replications. Where do we see the replications? Where are they? Yeah, so starting from the second row until one before last, right? So when we look at this line over here, what do we see about the meta-analytic effect size and confidence intervals? Yeah, so 0.04 from minus 0.07 to 0.14. So that's accurate, and this is this line over here. It's represented as a diamond because it's an aggregated effect. And here, is it significant or not significant? The null is included between the confidence intervals, so we fail to reject the null hypothesis. Therefore, we fail to find support for the alternative hypothesis. So if we look at the next one, how many of the replication studies, so from row 2 until 2 before, one before last, how many of the replication studies showed a significant result? And of those significant results, how many were in the same direction as the original? So in how many here do you see a significant effect? So what we're looking over here is we're looking at the null effect, the dotted line, and we're looking whether the confidence intervals of each one of the replications overlaps with the null or not. If we can't do this visually, we also have the confidence intervals over here, so we can see the range, and then we can see whether the 0 is included. So if it switches from negative to positive, we fail to find support. P-value is higher than 0.05. So how many do we have? Yeah, so 3, and out of those is 2. Over here. Yeah, so let's count them together. All right, so what do we have here? Which is the first one that seems to be significant? So if we look at this one by one, overlaps, 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 and then we have this one over here, just to make sure we also look at the numbers. So it starts from 0.01. So Ringus is the first one that's significant, and it seems to be in the same direction because it's a positive one. Then we keep going down, this overlaps, overlaps, and then we look at this one over here. It is significant, it doesn't overlap with the null, but it goes in the other direction, so it's negative, minus 0.51. And we can see that the highest one is minus 0.05. So we have another one that's significant, but it's not in the same direction, and then we go down and we found this one with Wolf et al. And then we see that this one also starts from 0.03, doesn't overlap with the null. Now we know that we have 3 significant, but a lot of replication studies, and a lot of them did not find anything overlap with the null. So a lot of failed replications here. 3 of them found significant findings, but only 2 of them are actually in the expected direction. So looking at the meta-analytic effect, looking at how many are significant and all that. Oh, one more question. Which of those studies has the largest sample size, and how do you know? So looking at this, how do you know which one has the largest sample size? 2 ways to know. What is the first way? The size of the square, yeah, so the effect size in the middle. The larger the square, the larger the sample. Good, that's one way. What's the second way? If we have larger samples, what does that mean? Yes, right. So the larger the samples, the more narrow the confidence intervals. Very good. So looking at these over here, which one has the largest? Sorry? Chung, yeah? I think that the Hong Kong representative in this replication. Good. So we see this also by looking at how big the rectangle is in the center, but also we can look at the difference, between the lower confidence intervals and the higher confidence intervals, how wide it is, and then choose the one that is the most narrow. Terrific. Overall, successful replication, no failed replication by 1. What's your conclusion? Yeah, you agree? Failed replication, a failed replication. Terrific. So we've done like a reminder. Now we feel like up to date about all of this. And now I'll tell you about this case study. So this is our summary of the RRR, replication register reports of ego depletion effect. And as you can see, this is just like we summarized this. This is the Cohen's D. Seems to be a very, very small, weak effect for something that's supposed to be one of our strongest phenomena. This is Rory Baumeister. He is the person who initiated this line of research. And this is the number of citations. I think this slide was done like 2 years ago. The number of citations for Rory Baumeister is 180,000. Do you know what is an H index or an I-10 index? You use Google Scholar, right, to look people up and see how yeah. Do you know what these numbers mean? What is this I index 528? What is that? You know? So I-10 is very easy. It's the number of publications the person has with more than 10 citations. Why 10? Because more than 90% of the literature nobody ever cites. It gets lost somewhere. Maybe the supervisor reads it and an external or the examiner reads it, but then it gets lost somewhere. So if you have more than 10 citations, it means that you've had some kind of impact. People have noticed your work. 528. By now, if you Google this guy, and you'll see the number of publications, it's more than 600. So if you consider a career of about, let's say, 30 years in academia, you have 620 articles a year. How many articles do you think an average academic does a year? I can tell you it's not 20. Nobody gets close to 20. So when a person like this is that prolific, it really shows very strong impact. What is the H index? Do you know what H index is? Slightly different. Roy Baumeister, at least 2 years ago, had 171 articles that had more than 171 citations. So that number is the number of articles that has that number of citations. So 170, most of us never get to 170, but he has more than 170 articles with 170 citations. I only have one paper that was published like very long ago on meta-analysis that has more than 200, but I don't even get anywhere close to this. So this is a very high impact scholar, definitely top thinker in our field, has done amazing work on all sorts of things like need for belonging, bad is stronger than good. You can see over here some of the citations from 2 years ago. The need to belong, bad is stronger than good. Look at the number of citations for this. Some of it is on par with prospect theory and Kahneman and Tversky. So in social psychology, Roy Baumeister is a big name. However, although willpower and self-control as a trait, as individual differences, if you remember the marshmallow studies, seems to be a solid phenomenon. We've been able to replicate this and it seems to hold. The concept of ego depletion, of a depleting ego, a depleting willpower, does not seem to hold very well. And this quote, I don't know what I would believe in social psychology if it were true that there is no ego depletion effect. We can understand how somebody like that, who started this, saw how much of an impact it had on the field, 2 decades of research, really does not, the RRR came out. He's like, what is this? Me and my team and a lot of people around the world have done this for a very long time. So the initial reaction by Roy and some of the ego depletion folks has not been very positive. But you can see the kind of reactions that the field and the media had to this failed replication, the end of ego depletion theory, the reduction of ego depletion, everything is crumbling. So there's all sorts of headlines that came out of it. And I think many people who did research on ego depletion felt very strongly impacted by this. It's a very sad story. I know some of the people involved. It has affected people's reputations and their careers. It's unfortunate because we would have wanted to know this a long time ago. Other replications that came out, some of our people here at HKU were involved in this. Finally, if we look at the entire history of ego depletion, we used to think 2010, like during my PhD, we really thought the first meta-analysis, there is an effect, and it's actually a quite considerable effect, 0.62, that seems to be above the typical effect. But then we realized that meta-analysis is not enough. We also need to account for publication bias. So we came up with some techniques, statistical techniques, to correct a meta-analysis. And when we corrected the meta-analysis, you can see over here the piece in PET, we see an effect sizes that are much closer to 0. And then all the other replications that came out 2016, 2018, the RRR, all of these. Hager in 2016 is the same Hager who did the original meta-analysis. So Hager was actually responding to all these failed replications saying, okay, we're going to do the adjustments for the meta-analysis for publication bias by saying we're going to do the largest one. So you can't say that Hager is anti-ego depletion. He is the one who published the meta-analysis that was the first to say this actually works and is quite strong. But altogether, when you look at this, it's kind of like the decline of ego depletion. And now it seems much closer to 0 than original. This is the original, the first reaction that Roy and Voss had to this, a misguided effort with elusive implications. However, they did their own RRR, and as you can see from this now, you know how to read this sort of thing. So when you look at this distribution, this is the null. Most of it is, the conclusions are 0.06, but it overlaps with the null. Therefore, the support for ego depletion is not strong, very, very weak effect, and it still, failed to reject the null hypothesis, even when you aggregate everything together. And look at some of these names here. I don't know how much you're familiar, but first of all, Hagar, you recognize Hagar. Michael Inslet, you've got a bunch of names, some of them from the ego depletion lab, some of them from the open science community. Very unfortunate, none of them are able to replicate the effect that was chosen by the ego depletion folks. So going back to Roy Baumeister's quote, I don't know what I believe in psychology, one of the strongest top social psychologists in the field. I don't know what I would believe in social psychology if ego depletion doesn't seem to hold. It's a disastrous kind of case study. So the coins, this seems to be 0.06 or 0.08, something that's very, very weak. Here is Sanjay over here tweeting about this live from a conference. But to me and many others in our field, this is the end of ego depletion. I just wanted to remind you about this from the first session. In the first session, I don't know if you were there or how much you understood this kind of distribution of effect, but now you're able to go back and read this paper in order to understand and assess this kind of replication, which is what you're doing in your tasks. Going back to priming, and this is going to be the last that you'll hear from me about priming. This is the last session that will deal with these things. We'll move on to other slightly more interesting and engaging topics after this, but I do feel like we need to say something about priming. And this one also holds a special place in my heart because it has a connection to us here in Hong Kong. This is a classic paper by Srull and Wyer from 1979. You can see that this was done, it's published in this new journal, which is very, very impactful. You can see a very large team. Randy is here, the leader, but we've got a lot of people in the open science community who are here. Many of them I know personally or collaborate with. So this seems to be a very large attempt in order to replicate a study from Journal of Personality and Social Psychology, top journal in social psychology in our field. And the nice thing is that the protocol for the replication actually was vetted. It was checked by one of the original authors, which is Robert Wyer. So it's a replication of his work from 1979, but still in 2018, he's still alive, well, and active in academia enough to go and vet this thing and help the replicators, which is what really original authors need to do a lot more. Now, the conclusions by Randy and the team over here is that although the confidence intervals for one outcome excluded 0 and the observed effect was in the predicted direction, these results suggest that the currently used methods do not produce an assimilative priming effect that is practically and routinely detectable. So a lot of doubts about this thing. First about Robert Wyer. He is actually here in Hong Kong with his wife. I studied with HKUST, and he is in the marketing department. I used to be in the business school studying management, and he was just across the hall from me. He then moved to Chinese University of Hong Kong, and he's still around. He still publishes with a lot of Hong Kong students in various universities. He's a well-known name here. Not just him, but also his wife. They both moved here to Hong Kong. She's, I think, still in the marketing department at HKUST. And I know them to be very warm, nice, friendly people, give amazing seminars. It's always a treat to listen to them talk and hear from them. And he really encourages students and he works well with students. And every year he comes out with a lot of interesting findings. And really a lot of his career is related to, associated with the priming effects. If you look at his profile, so now we know what H index is and what I10 is. So he has 188 publications that have more than 10 citations. So definitely an impactful researchers. We don't have a lot of researchers like that in psychology, marketing, management in Hong Kong. So for us, it was a big name coming to Hong Kong to help us improve and learn. So it's amazing that he chose Hong Kong as a home for himself. And you can see that the top citations are the automacy of everyday life. So these priming effects, 2,700 citations, advances in social cognition about the dual process model of impression formation, and all sorts of things about memory and priming. Unlike John Barge, whose reaction to replication were very negative and dismissive, this is not the case with Bob Wyer. So he was really helping the replicators and working together with them. And I think this is the kind of humble attitude that you should have, and be open as a scientist to having other people revisit your stuff. This is from Randy for an interview that he did with the Center of Open Science, which he is affiliated with. You can see him wearing the t-shirt over here. This is from the interview. And his conclusion is, collectively, it seems like the original hypothesis was not interrogated very rigorously. He came to this conclusion not just because the replication failed, but also when he did what you're doing, when he did an assessment of the original article, he noticed things that actually don't make much sense. So it could be that when you go over the original, or even when you go over the thesis or stuff that was done with me, you'll see some numbers and you'll kind of like, what is going on here? This doesn't seem plausible. And I want to give you an example of findings that don't seem plausible so that you'll know what to look for. Here's an example for one of the replications that he did before to a study that was done by Nathan DeWall. Actually, Nathan comes and visits us in Hong Kong every once in a while when there's no pandemic. He was here at least twice since I came to HKU. To share with us. He is now the lead author of the book, the textbook for social psychology, so very impactful in our field. He's also a previous graduate of the Baumeister Lab, so they've worked a lot together. Very, very important person in our field, and a leader of sorts in his domains. So he did quite a bit of things about like hostile, aggressive thoughts, and as you can see, again, using the John Barge methods of words associated with hot temperature, increase aggressive thoughts and hostile perceptions. You can see that Randy was one of the first to really try and do replications when nobody else was doing replications, and he was one of the first to actually be able to get those published in 2014. And the original findings show strong link in memory between words related to hot temperature and aggressive thoughts and biases. But what Randy actually found is these replication attempts failed to find any evidence for exposure to heat primes as affecting hostile perception relating to all of that. In addition, Randy was also involved in some other things, and there's more evidence that priming just doesn't seem to work. For example, this priming literature, priming heat, increases belief in global warming. So, on hot days, people believe like global warming is more of a real phenomenon than in cold days. But then when they tried to replicate the whole thing, they found a Cohen's d of minus 0.03. Once again, you can see the number of people involved, people taking out of their time and their resources and their funding in order to revisit this work. But really, a lot of investment. Now, I want to show you what Randy posted on Twitter. I'm very active on Twitter, and I follow these people in the open science community to try and learn from them. And Randy posted about a meta-analysis of the priming effects. And when he saw this meta-analysis of Srull and Wyer included in the meta-analysis, so just like we saw in the RR assessment, you have a summary on the side of the effect size. Here, you can see that he saw all the effect sizes. So effect size for priming sometimes is 0.02, sometimes is 0.39, 0.08, and then he saw 5.65. Not 1, not 0.8, 5.6 in the original paper from 1979 that has been cited more than 2,000 times. So he went back to look at this, and it seems like the effect size was calculated from this F statistic. That F statistic, using a small sample of 80, I don't know why these degrees of freedom, but never mind that now. 123.74. This is completely unreasonable. So Randy was trying to explain to others why this is unreasonable. And it's amazing that Randy needs to explain this to people who do statistics for a living and research for a living. And this is what he writes. Females have a mean height of 65 inches, which is 165 centimeters. If we compare males and females, a Cohen's d of 5.6 would be if males had a mean height of 85. So this is the differences between males and females if the effect size is 5.6. So 5.6 is such a visibly strong effect that he tried to show this. What is 215? It's a bit like these differences. So if Shaq, who was a big NBA player back in my time, was the typical average male, this is what an effect size of 5.6 looks like, the differences between these two. So everybody is kind of like, oh yes, you're right. Register replication report primary effect throws doubts at this incredible result. There is nothing that we do in psychology, absolutely zilch, that is 5.7 Cohen's d. Nothing like that. When you see something like that, this is an error. Actually, I will tell you, if you find something more than 1.5, very, very unlikely. More than 1, we need to look at this. So generally, a good way for you to assess things is look at the effect sizes and see whether this is plausible or implausible, especially given such a very small number. Another thing that you can do in your RR assessment, so how do we know this? Okay, so now we know that we can look at effect. Any other ways that we can look at this? So other people, for example, James Heathers over here, we'll come back to James Heathers because he quit academia because I think he's just very angry about all sorts of things. He still has a podcast called Everything Hurts, Hurts with a H-E-R-T-Z, Everything Hurts, where he discusses his adventures with checking people's work. He is one of the first that actually dedicated their time to examining and developing tools on how to check people's statistics. It's too bad that he's not in academia anymore, but I think he's very happy about this and he's making a lot more money than us for sure. But he still comments about these things. So for example, in this tweet, he wrote, Srull and Wyer in 1979 that we all rely on did a 4-way interaction. Not a 1-way where you have, I don't know, 3 conditions, for example. Not a 2-way like a 3x2 or 2x2 like some of you have in your replication targets, but a 2x2x2x2 or 2x3x3x3. 4-way interaction where you manipulate 4 different things. And this 4-way interaction is something that had a p-value just below 0.02. So that's already, if you have a lot of interactions and they're just below 0.05, then you really need to ask yourself, was this really pre-registered, hypothesized in advance? I don't know. 4-way interactions, I can barely understand 2-way interaction. Understanding 4-way interaction, you really need to be a genius for that. Plus, if you look at this plot, for a very small sample, this plot is just too perfect. Everything just goes exactly in the same direction. So usually we expect some messiness. When you look at the plot, there should be something there that shows a distribution of some noise and things spread around and all that. But this is just too clean. So Brian Nosek, who is the founder of the Center of Open Science, that's responsible for the open science framework that we use to share all our data, do all our pre-registration. So the director of the Center of Open Science says, did you look at the figures in Srull and Wyer? They are perfect with a very small n per cell. So if we had a very large samples and the effect was very strong, maybe this is somehow plausible. But n per cell is 8. You expect very large variations, a lot of error. This is impossible. So the data reported in the figure are extremely unlikely. And then Randy, yep, perfectly orderly, nice decay effect, all between subject design, n equals 8 per cell. It's hard to explain. So they went back to Bob Wyer, who was involved in this, and they asked him, so what's going on here? And Bob Wyer says, yes, you found a mistake. This seems like a mistake. I don't know what happened there. Now, if we would be truly a science, we would be able to go and look at the data. Please show us the data. But who keeps records of effects? Who keeps results? Definitely not from 1979. Just go to any scholar, not just in psychology, and ask them for something from 5 years ago. Can you please show us the results? Nobody has the results. We don't do a good enough job at keeping track of our results, so we can't really check this error. These are some slides that Randy showed. You have a section in your R assessment, why replicate these results? So he was saying things like, number of citations over time, and it seems to be increasing, and it's like over 2,000 something now. So there's a lot of reasons to replicate this. It's been foundational for priming work in all sorts of domains. It's been used, the Donald vignette has been used in many dozen subsequent studies. By the way, just an interesting anecdote. The original vignette used Donald, but in the replication, they used Ronald because back then Donald Trump was raising his head a little bit, so they really wanted to move away from Donald, and they used the Ronald. Anyway, it's interesting, but the Ronald vignette has been used many times. And then implausibly large effects that don't seem reasonable at all. And then the final conclusion is we ought to seriously decrease our confidence in these sorts of methods to produce hostile priming effects. And now, just like ego depletion and the stuff that John Barge is doing with priming, we just don't think that these hostility priming effects work anymore. So another error, which is another reminder that please check our work. I don't want 50 years after I publish something for somebody to find this kind of stuff in our work together. So please help me and our students do better by checking us, replicating us. I'm willing to pay a lot of money for this just to make sure that I can sleep at night. So since then, we've had more attempts. So the first attempt came out and people said, even with the error that you detected and even with the failed replication, maybe it's just because there's been, 50 years since then. Sorry, 40 years since then. Maybe just like things changed. Let's try this again. And people are like, oh, again, like getting everybody together and investing all this work. Look at the number of people, this like Randy, poor Randy, again, was able to get another 11 authors together to do this kind of thing. Look at all these labs that are involved. There's another replication attempt, investing even more in this. And they're not just doing the original replication, but also doing a conceptual replication. So much money and time and resources wasted on this, only to show that the hostile priming effect for both the close replication and the conceptual replication were not significantly different from zero. So you can see that after something is published, especially if it comes in Science and Nature and JPSP and psychological science, it's very, very difficult to get that kicked out of the literature. See how many people were involved just to kick out one paper that was done by John Barge and a student, or by two people in 1979? Why? Because over the last 40 years, we've brainwashed ourselves and you to say, no, this works, this works. Did TED Talks, we published books, we did all sorts of things. So now we need 2 attempts, both for ego depletion, 40 labs plus 24 labs. And then here with Randy, poor Randy, again and again, people are saying, no, but maybe this, but maybe that. Just how many replications do you need just to get rid of one effect that everybody keeps citing in the literature? So really a lot for us to take away from this, which we'll summarize with a reference to a very important book that came out a few years ago by the same person who invented register reports. So this is Chris Chambers, who's revolutionizing the science field overall, not just in psychology. So what we're doing is a register reports, and we have Chris Chambers to thank for. At the beginning, Chris was not very well known, but then he came out with this book and he started doing editing a register report. 7 Deadly Sins of Psychology. Back then in 2014, we thought this is just psychology. I think now we can safely call this the 7 Sins of Science. So he does wonderful work at summarizing this. I have a few copies in my room if you want to borrow this. So 7 Deadly Sins of Psychology. Sin number 1, and we're going to discuss this in next lectures. We're going to do some demonstrations of this. There's outcome bias. So looking at whether the outcome is positive or negative affects your evaluation of the quality of what was done. So if a medical decision, even if the medical decision is a very good one, but it led to the death of somebody rather than saving the life, then we say, oh, it led to the death, therefore it's a bad decision. But you need to evaluate the decision based on the decision, not based on the outcome. So outcome bias is a very big problem for us in the literature because people say positive findings and negative findings. Your p-value lower than 0.05, terrific, you did amazing work. Higher than 0.05, you didn't do work very well. So outcome bias really is one of the sources for why we used to not publish any replications. Confirmation bias is that, John Barge, I've published this many times. I know that this works, but you only collect the evidence that supports your own views. And we really need to have, the open-mindedness of looking at everything out there and questioning our beliefs, having a scientist a scientist mindset to really re-examine all of our assumptions to see, are we just confirming to our own beliefs, or can we perhaps include some other evidence, scientific, rigorous evidence in order to change? Publication bias, we've talked many times, hindsight bias related to outcome bias, and we'll talk about this in the future. We've shown all sorts of indications for publication bias with all these positive results. It's not just in psychology, although psychology is really the top for this in over 90%, but even with other fields, even up to the space science, very large proportions, over 70% that are positive finding. So it's not just psychology, it's happening across the field. This hindsight bias of we knew it all along, or when we look at the results, we go back to the hypothesis and we change this. So basically, rather than having a target and then shooting into the target and then trying to nail the middle, first we shoot and then we draw the targets around it, which is, I think, a really good representation of what harking is, hypothesizing after the results are known. And then self-report says that 40% have observed harking by colleagues and almost 60% suspect harking by colleagues. So we're not talking about one or two occasionally every once in a while. We're talking about entire scientific field that's doing this and not just in psychology. I really like this one. So this is another group, another team will be assigned to this cognitive bias, and it's called fooled by randomness. I think this is an especially bad situation now with COVID, where there's a lot of misinformation and we see, oh, this is happening and this is happening, and they're happening at the same time, therefore they're connected. So if you go to this website, spurious correlations, you'll see a lot of examples for that, and I'll give you some examples for all sorts of things that just don't make any sense, but very large correlations. If you want to read more about this, also in my room, you're welcome to come and borrow this. Is fooled by randomness. So scientists may be in the business of laughing at their predecessors, but owing to an array of human mental dispositions, few realize that someone will laugh at their beliefs in the future. So one of the things that we really need to pay attention to, we criticize, we assess what others have done, but we really need to also do this with ourselves. Perhaps what we're doing right now is not ideal. Maybe in 10 years, somebody will come and look at what we're doing now and say, this doesn't make any sense. So humility is very, very important. Being able to question our assumptions, to revisit our own work, and share as much as possible so everybody else can check what it is that we're doing, so that we make sure that we're not fooled by what it is that we're observing in our world. I really like this example. So in 1976, started coming all these images from space and the moon. So at the beginning, people were saying, oh my God, look at this, there's a face on the moon. So that's an example for an alien civilization. And they already have the base in the moon. They're coming here to attack us. So there was a lot of things over there in regards to what we should do about the identified face on the moon. But then in 1998, we had a slightly better resolution. But even here, people are saying, no, I can still see a face. Okay, in 2001, this is what it looks like. And it's just like a hill on the moon. So don't need to think too much about it. And Even in 1976, you need to be very, very careful because you need to understand that you have a lot of noise. So maybe you see a face, but you need to ask yourself, is my technology good enough? Am I accurate enough? Perhaps we need to wait with this and we need to collect more evidence before we jump into conclusions about alien civilizations. Some really interesting correlations. I love that website. Go and have a look. It does all sorts of things. So a correlation of almost one, correlation of one between what? US spending on science, space, and technology, and number of suicides by hanging, strangulation, and suffocation. What is the conclusion? The only reason why people are committing suicide is because the US is spending money on science, space, and technology. Because correlation and causation, of course, we mix them. Correlation of one, very strong evidence, p-value lower than 0.000001. So therefore, evidence, we must stop funding the US science. So need to be very, very careful with this. There could be all sorts of things that are explaining this, even stranger correlations. I don't know if you're familiar with Nicolas Cage. He was a big actor during my time. So this is the number of films that he appeared. This is my time, 1999, 2000, 2001. So almost 2 films, 3 films, 4 films every year. Number of people who drowned by falling into a pool. So it seems like Nicolas Cage is either causing this or is affected by this in some way. But this is a smaller correlation, just 66.6. Divorce rate in Maine and per capita consumption of margarine. Worldwide non-commercial space launches and sociology doctorates awarded. Correlation of 88. Japanese passenger cars sold in the US and suicides by crashing of motor vehicles. Almost a correlation of 1. The Japanese are causing everything that's bad in the US. So quite amazing to see these sort of things. And then you really have to wonder, like, our mind is used to identifying patterns in all of this, but when you see a pattern, really take a step back and think, does this make any sense? Is this just, nature, universe, randomness, noise doing its thing, or maybe there's something solid about this? Another way to look at this is like, okay, we observed something, it's an interesting exploratory hypothesis. Now, can we replicate this again? So let's look at a decade afterwards. Does the pattern still repeat or not? And it most likely does not. So that's another very important aspect of a replication. You see something good, you've explored, you even identified a correlation of 1. You pre-register this. You say, I expect a correlation of 1 between Japanese passenger cars sold in the US and suicides, and let's see if the following decades this still holds, and it does not. So we need to test again and again all of our assumptions over here. Sin of hidden flexibility. So we talked about p-hacking and selective reporting. In our department, we have a lot of neuroscientists. Perhaps you belong to one of these labs. You have to understand that when we do neuroscience, we have a lot of flexibility. How much flexibility do we have? So this is all the flexibility. So we have 4 options, at least, for motion correction, 3 for slice timing correction, 2 for field map, 3 for smoothing, 2. So for each one of these things, it's a step in how you interpret neuroimaging. But each one of those, you have a fork. You need to decide which path you're going to go. If you combine all these steps and all the forks, you'll see that you have 69,000 ways of choosing your analysis. Perhaps you found a p-value lower than 0.05, but for which analysis? For all of them? For one of them out of 70,000? So we need a lot of humility. We need to make sure that everybody would follow the same path as you. If we give them exactly the same decision, would you follow in this path? Now we have ways to deal with this flexibility, but up until not too long ago, and still in some fields until today, people just take this flexibility and say, yeah, this is how we do. We choose because we know what we're doing. Others don't need to know, so we don't even need to report this. So when you're assessing things, I really want you to assess have they used flexibility? Did they constrain themselves? So when you look at the pre-registrations, are the pre-registrations really specified and identified? Somebody was asking me on Slack yesterday, was saying, you pre-registered 4 pre-registrations, which is right. We crowdsourced. We had a team of 4. Each one of them, you don't have to do this, but each one of them wrote a pre-registration, and I pre-registered all of them. And then in our report, we said we're going to use the strictest of all of those. Great, but then the group is asking, but which one is the strictest? There's 4 of them. Which one should we go after? How did you decide what's strictest? Very good comment. We did not specify this well enough. So we did an amazing job. 4 people did pre-registrations, but a lot of flexibility. Are we choosing this one or this one? How do we choose what is strictest? Please define what strict is. So it's very important to reduce your flexibility. So when you're doing your applications and extensions and you're writing your pre-registration and you have all these flexibility on which option to choose in Jamovi, or what is it to run in your Qualtrics, please explain so other people will be able to follow this. This is why we share all of our Qualtrics. We share all of our Jamovi files so other people will know exactly which option we used where. But when you do neuroimaging in any of the labs here at HQ or worldwide, a lot of things are implicit and are not shared. And we need to understand that this flexibility might mean that we're identifying, we're detecting effects that are not actually there. So a lot of papers on this, for example, the Secret Lives of Experiments Methods Reporting the fMRI Literature, looked at 241 published fMRI studies. Around 50% did not provide enough detail to be replicated. All sorts of unique analysis pipelines, lots of research coming out on, we don't actually know what they did in this neuroimaging study. Even if we had the same data, we don't know how to interpret this. What did they do here? Why did they choose this one and not that one? So a lot of problems, and Chris Chambers is calling this a sin. And I agree, we need to reduce, we need to address this sin of flexibility. So we can do pre-registrations, which is what you're doing, but we need to do pre-registrations well. We need to publish research based on the importance of theory in question and rigor, regardless of the results. So we shouldn't take the results into consideration. We should publish all of the paths that we've explored, not just the one that led to p-value lower than 0.05. And in the multiverse, analysis is now a new method where we explore all of the paths together, and then we summarize which ones worked and which one are the more likely of those. It's not for you, it's a different method for if you continue to postgraduate or become academics, but now we have more and more methods coming out since 2016 on how to do a multiverse and how do you increase transparency about everything that you've explored in every possible path. Unreliability, sin of unreliability, so the failure of rigor and self-correction. So we don't do replications, we don't do enough statistical power analyses, all sorts of other problems. And even when we identify problems, if you go to Srull and Wyer 1979, we already know that there's an error in there because the original author said so. We already know that this doesn't replicate once, it doesn't replicate twice, but it's still there. Nothing on the article actually says that there's a problem there. So let's say that you're a thesis student and you go and you say, oh, cited 2,600 times. Let's do my work on this. But so many labs have already wasted so much time, but there's no indication in the actual website on the paper that this is a problem. So we're not very good at retracting anything. So replications, how often do they occur? Not enough, which is what we're trying to fix in this course. And then refusal to publish negative findings in the literature. So now we've looked at this very rigorously, ways to deal with this. And the final thing that I want to discuss with you before we go is the sin of data hoarding. A lot of people don't share data. I think that if you'll go to your labs and you'll talk to the PI, it's like, can we please share the data? Even from your thesis, some of them would say, no, I don't want to share this because, somebody will scoop me and I want to publish more with this. And there's all sorts of reasons why people don't share their data, but this is wrong for so many reasons. First of all, you paid for it. You're the taxpayers. You're the ones that finance me, finance the funding. This belongs to you. It doesn't belong to us. Therefore, it needs to be shared. But then, once again, we can't verify this. We don't know whether this is solid and reliable, and we can't aggregate this. So, for example, different people can do all sorts of things about COVID vaccines. So, we've got a sample here, a sample there. If everybody keeps this to themselves in the middle of the pandemic, if we don't share this, we won't know how fast this can be implemented, whether this is safe, whether there's side effects. So if we keep holding everything to ourselves and we don't share this as a community, this can have severe consequences for us and for people's lives and health. So I share everything that I have. I know that some people have some hesitation about this, perhaps saying things about we care about privacy, but whatever your concern is, there's a way to deal with it. Right now, I don't see any excuse why not to share data, or at least explain why you're keeping something and use alternative methods like simulating the results. So there's no reason why anybody would keep the data for themselves. So I think this is a really, really big sin. We could have solved a lot of issues if we just shared everything that we had. All right, so this summarizes this session. Starting from next session, we'll start looking at very different things about social psychology, findings, a bit more of an optimistic view on things. Thanks for bearing with me for 4 lectures about statistics and open science and the science crisis. I know it's not easy, but now that you've survived this, moving forward, I think it will be a lot more engaging and interesting for you. So looking forward to that.